Hello, everybody. Welcome to today's webinar, Getting Started with Docker. Looks like we have some more people joining on, but I'm going to go ahead and get started because we're going to go pretty quickly. Should be about an hour. We might run over a little bit, but yeah, again, thanks for joining. My name is Peter McKee. I'm the head of developer relations here at Docker. And today I'm going to be going over getting started with Docker. We already had a question. What prerequisites do you need? Do you have to know anything? No, we will start at the very beginning and go from there. So if you would like, let me start sharing my screen. No, didn't want that. Okay, hopefully everybody can see my screen. So if you would like to follow along or go through the tutorial later on your own, two ways you can find it is you can go to GitHub, Docker, getting started, sorry, and basically run this little bit of code here. You need to have Docker installed, and that will start the tutorial. This is exactly what we're going to do today. Another way to get started is if you go into your dashboard on Docker Desktop, and you will see, actually, the quickest way is actually from the menu, go to the Quick Start Guide. That'll drop you into our Quick Starting Guide, which will walk you through about 3 or 4 steps, and then you can start into the main tutorial. So those are two ways to get to the getting started. So what I'm going to do is I just navigated here to GitHub, getting started page. Let me scroll down, and I'm going to copy in this Docker command. So we're going to run a Docker run command. Don't worry about what this command does right now. We actually walk through it. And I'm going to jump over into my terminal. I'm going to run that command. Let me bump this up so we can see it. Okay, there we go. And so what that did is it started up a container. And now I'm going to go into my browser and go to localhost. And there we go. There's our tutorial. It's as simple as that. And so what this beginning of this bit, it kind of explains exactly what we just did. So we ran a command called docker run, and then we passed it in some flags. The first flag that we passed in is a -d, and that'll run your container in detached mode. So basically in the background. -p is to expose ports. So we're exposing and mapping port 80 on my system, on the host system, to port 80 inside the container. And we're going to get to networking in a little bit. But so this allows the container, usually containers are run in isolation, and that includes the network. And when we publish, the -p stands for publish, that'll publish the port. It'll publish port 80 and map it into port 80. So that allows network traffic to get through the firewall and into your container. And then the name of the image that I start is called Docker Getting Started. Okay, so after we start up, let's go ahead and take a look at our running containers. So with Docker Desktop, it has a dashboard. So let me open back up the dashboard. So here's the Docker Desktop dashboard. And I'm in containers and apps. And we can see here that I'm running a container. It tells me that it's running and it's listening on port 80. It assigns a random name when you don't give your container a name. So that's where this name comes from. And then it tells you what image. And then here's some different commands you can do. This will open it in a browser. This will give you a CLI into that container. This will stop the container. You can restart it. And then you can also delete it or remove it. Okay, so what is a container? So and I'm not going to read line for line here, but basically what a container is, it's a process like a normal operating system process that runs on your system, but it's been isolated from the rest of the machine. So isolated from other resources on the machine, such as CPU, memory, network, other files that are on the system. You can isolate that process to not be able to even see those files or system properties, right? It doesn't even know that those are there. So this is a really, really good video by Liz. She's a Docker captain. If you get a chance, download this image and run it, and then link into this video and watch this video. It goes a little bit deep underneath the covers on how exactly containers work, but it's very informative. And the nice thing you kind of get out of there is how Docker containers are made up of a file system and a process. So what's an image? So if you're a developer out there, you can kind of think of as images in containers as object-oriented programming. So with object-oriented programming, we have classes and we have objects. A class is a template for an object. So when you write code, you say new class, and that creates a new class and returns an object to you. So an object is an instance of a class. Same in the container world. So an image is a template of a container. So you can think of an image as a class almost. So it's a template. It defines what files are in there, what processes are going to run, what ports are going to be exposed, all those type of things. And then when you run an image, you run an image inside of a container. And a container is a running image that's been isolated. All right. So let's jump ahead. Let's go next. And we're going to take a look at an application we're going to build. So this is an MVP, a little to-do app. It's written in Node. Don't worry about that. You don't need to really know a lot of JavaScript or Node or any at all in this tutorial. We're not going to be writing a bunch of code, JavaScript code. So let's go ahead and download our app, and then we're going to open it up into Visual Studio. So I downloaded that. Let's go. I'm going to go into my sandbox. I'm going to make a directory, so getting started. And I'm going to copy that file I just downloaded from downloads. And I think it's app to here. And I think I have unzip. There we go. So let's go into app, and then I'm going to open up it in my code editor. Let me bring this over so everybody can see it. And let me make it nice and big. Whoa, that's a little too big. Okay, there we go. So a couple things here. You can see the package JSON in two subdirectories, source and the spec. So let's just go ahead and take a look at it. So in our source is where we have our actual code running, JavaScript code. I won't run down through this, but this is basically setting up routes. And then in here is how you handle the routes. And then we have some testing going on, SQLite, some testing to set some data up. Okay, so that's our application. So we're going to build our image. And the way you do that is you use a Docker file. So Docker files are basically is a text file that has a set of commands in it that the Docker engine will run down one by one, reading in these commands, and will produce an image for you. So let's go ahead and create a file. Let me close these up. Okay, and we're going to create a new file. And let's do it like that. There we go. And we're going to call it a Docker file. And then we're going to paste these commands into it. I'm going to put some white space because I like to see some white space in here, right? So let's go back, sorry. So let me walk down through these commands pretty briefly. So from command tells Docker that we're going to use the base image called node, and it has a tag 12-alpine. So an image is made up of a name and a tag, and a name is the image. Sometimes you'll have a repository at the beginning. So that's my repository on Hub. And then you have the name of the image, which is node, and then you have the tag. So since Node is an official package, the repository is assumed to be Docker. And the tag is Node version 12, and it's using Alpine as its base image. Alpine's a slim Linux distribution. It's very popular when you're building images. And right here, we're going to create a working directory. And what a working directory, it's a way that you can write relative paths later on in subsequent commands in your Docker file. So here we set up, hey, we want to create a working directory called app, and every one of the commands that are executed below it should assume that that's the directory working in. So down here on line 5, we copy everything in the current folder on my local machine into the current working directory inside of the image. So that's what the periods are for. It says in my current directory, and the copy has the format of copy from to. So from my local directory into the local directory in the image, and that local directory in the image is the app because we set our working directory. And then we're going to run yarn install. This is, if you're not familiar with Node and yarn, this is just basically the package manager. And so it does an install. It'll look in your package JSON and will install all of these dependencies. And then we give it a command. The command tells Docker what command you actually want to run when your image is started. So when your image is started and run inside of a container. So it's going to run node, and it's going to pass to it the source index.js. And what that is the main, the main file that will start to get executed and set everything up for us. So that's a pretty quick run through of a Docker file. And so to build our image, we're going to use this docker build command. So let me copy this, and then I'll talk about it as it's running. Let me clear this. So let's do this first. I'm going to show the help. So you can have a ton of different flags that you can, and options you can pass into it. The main options are you give it the path on where your Docker file is located. You can also build from a URL, and then you can give it a context. Where's the context you want to build? What working directory should Docker should use for when you do things like the dot? Okay. And then you can come down here and you can do all kinds of different things. Don't stress about these right now. 90+% of the time, you'll just run a Docker. Docker build. Sorry for the fast switching. Okay. So we're going to do a Docker build. We're going to give it a -t, which says tag, which is basically how you name your image. And then we're going to call it getting started. And then we're going to give it a dot for the current directory we're in. And that's our context that we want Docker to use to build. So let's run that. Let's jump back into here. So basically just walk down through what this text here basically walks down, describes on what I just talked about, what's actually happening when you do a build with the Docker file. Okay, so as that's building, we'll let that finish. Let me jump over. So let me explain what's going on here. So we loaded in the docker ignore .docker ignore. This tells Docker, it's just like a get ignore or any other kind of ignore file. It tells Docker, hey, don't worry about these files or folders and those type of things. And then it's going to pull down the node 12. It's going to unpack everything, extracts everything, and then it loads in the context. It sends the context to the Docker engine to build your application. And then it starts walking down the different commands that you have in your Docker file. And then at the end, it says here, we're writing image, and then it's going to say it's naming it. And that's when it does the tagging, and it says this image is now getting started. So let's clear that. So our build has been run. Okay. Now we can start an image very simply by doing a Docker run. And that is this command right here. So let me put it into the terminal and we'll kind of talk about it. So Docker run tells Docker what image to use to start a container. And we can pass in different flags also to the run command. So we're going to pass in a -d. I'm going to break these out. So we pass in a -d to run it as a daemon, as you saw when we actually started the tutorial, right? And then we did a -p to tell it what port to listen on. And then we're giving it, we're mapping the ports 3000 on my local machine to 3000 inside of that machine. And then it says use the getting started image. Okay. Let's go ahead and run it. So now it's running. After a few seconds, we can open up our local browser. So I'm gonna do that in a new window here. So I'm gonna go localhost 3000, and there it is. So now we can add items, remove items, we can check items, those type of things. Okay. Sorry. So there we are. There it's running. Now let's go take a look at back into the Docker desktop. And now we can see, oh, we have another image running, which is called bold pane. We can see the status it's running. It's on port 3000. And the name of the image is getting started. And then we have the same options we can do here. Okay. So let's make this is talking about a small feature request comes in. And so let's go ahead and make the feature change. And then we'll rebuild our image and then we'll rerun it and we'll see the changes inside of our container. So in source static.js app.js file, update line 56. So static.js, and it was the app, correct? Yep. Okay. And let's go to line 56. Oh, yuck. Let's get rid of these. Okay. So we basically, why don't you like that? Don't like that nasty red line. Okay, well, we'll see what happens. So now that we made the change, let's go ahead and build the image again. It is back on the last screen. Okay, let's clear this and I'm gonna go up a couple. So that is the same exact command. We're gonna run that again. This is gonna build our image again. It's gonna do the same exact steps. It reads in the Docker file, looks at the Docker ignores all those files, grabs the contents of our context, sends it to the Docker engine. We already have the node image downloaded. And then it's going to start walking through the steps. Working out, copies, run yarn, and then it'll now create our image and then tags it. Okay. So let's stop our image for a second, and then we'll restart it. Oh, it's actually going to say it shows right here. So let's copy that. So I'm going to run docker run -d -p. -d is for a daemon to run it in the background. -p again is to expose the port. 3000 mapping into 3000. And we get an error, right? That's because we already have a container running. On port 3000. So it's not able external connectivity on the endpoint. So let's clear that. So what we have to do here is let's grab the ID. So let's clear this. So we can do docker ps. So we can see a list of images that are running on our machine. And actually, when I bumped up the resolution, it makes my window too big. So docker ps. So there's a list of our images. This first image is the one we just started a couple minutes ago, about 4 minutes ago. And the other one we started 17 minutes ago. This is the Docker getting started. This is the actual tutorial that's running. And then this image is the image that we just tried to build and run. But you can see right here that we have port 3000 already mapped in the 3000. And so port 3000 is being used already on our local machine. So we're not able to map another port to it. So we have to stop this image and then remove it. So bold pane is the name of it. So we want to do, Docker stop. And now if we do a Docker PS, we don't see it running. And then once, what this is saying right here is the container is still there, it is just stopped. So if we tried to restart, we start it again, should be started up, right? So now we're going to have Docker PS. We have our 2 images. But to see the full list, so Docker containers are in a couple different states. So they can be started, they can be stopped, they can be created, those type of things. But the main 2 statuses you have of a container is either started and stopped, right? And so now we have bold pane here. We want to remove this image because we can see it exited about 31 seconds ago. So we're going to do a Docker remove, and we're going to, well, that's not the name of the image. I'll just type it in. So bold pane. So that tells Docker, okay, remove this image, get rid of it. I don't need it anymore. I'm sorry, remove this container. Pardon me. Remove this container. I don't need it anymore. I have another one running, or I want to start another one, right? So now if we do a Docker PS-A, we can see that it's gone, right? Okay. And then also you can see these back in the Docker desktop. You can see your containers and apps running. So we still have our tutorial running. We have Eric Thomas that's been created, and then we have one that's starting. Oh, we can get rid of this. Let's delete that and remove it. Okay. And then if we do a Docker PS-A again, a -A is for all, shows you everything. Now you can see that Eric Thompson, excuse me, has been removed and is no longer there. But we still have our other containers running. We have one on 3000 and one port 80. If we go look at our application, let's refresh that. Uh-oh. Let me get the name of it. Don't like that this wraps, it's hard to get the name. Oh, seems to be running fine. Let's stop it. Docker stop. Wells. Let's remove it. Okay, now let's run it again. Okay. Here it is again, running on port 3000. That is really weird. Let's look at the logs. Of course, this has got to happen to me right in the middle of a tutorial. Well, okay. And we should only, okay, we only have that running. Okay, Let's rebuild it again. Okay. Docker run. Let me clear the screen, sorry. Docker ps -a. So there it is again. There we go. Not sure what happened there. Okay, so get milk, get soda, get snacks. Okay, cool. Let's check that one off. Let's delete this one. Okay, seems to be working fine. So let's go back to our tutorial. So let's do that now. So you can also use the Docker UI, the desktop dashboard, to delete an image like we did before, but let's go ahead and do it with this one. So you can see that how I can tell which one is which, right? So Docker / getting started is my tutorial. Just the getting started image is the image that we created. And so let's delete it. And there we go. And let's confirm on the command line. It's not running, ps-a, and we can see it's been totally removed. Okay. We've already restarted our app. Oh, let's go, we didn't put the change in there. Let's put the change back in there. Oh, I know what the change is. It's not gonna let me do it. I did this last time. Oh, these colors in here are horrible. We want to add this line. Let me put it below so you can see the change. Okay, so it's complaining because if we did this, sorry for all you React folks, we're probably screaming on the webinar here. Okay. So this was the original text. So we wanted to change the text that's in there. So you have no to-do items yet. Add one above, right? So let's remove this. We'll save that. And let's build our image -t and getting started. We'll give it the local context. So it's going to run, builds our image again. Let me look at the questions while that's running. It doesn't let you make the questions bigger. Of course not. There we go. Yes, the workshop's being recorded. You need to install Docker Desktop on your laptop or your local workstation to have Docker installed to follow along. You got it, Ivan. You were telling me how to fix there. Yep, it needs to be wrapped in a div. Okay, awesome. Let's carry on. Okay, so we built our image, and now let's run it again. So we just built it, and now let's run it again. Let me copy that. Docker ps, so we can see it running on 3000. Whoop. And now you can see we have our updated text in the image, in our new container. And this is what we just did. Docker ps will list out your containers. Docker stop stops a container, and then once it stops, you can remove it. And here's where we just restarted our application. Okay, so now let's take a look at sharing out our image with the rest of the world. So I'm going to go to hub.docker.com. And I'm going to sign in. If you don't have a Docker ID, you can create one. Thought I could remember my password. Okay. Well, let's fix that. Everybody look away. Just kidding. Get out of the way. Let me grab my password, 1 minute. Okay, there we go. Okay, so we're going to click on the new repository button. We're going to name it Getting Started, and then we're going to make sure it's public. So I'm going to create a new repository. It's going to be underneath my account. I'm going to name it Getting Started. I'm also going to keep it public. And then we're going to do a create. Okay, there we go. And you can see here that this tells us the command on how to get our image into Hub. So Docker push pmkey getting started. So back on the command line, we can run that Docker push command, and that will push our image into Hub. So let's do that. I think I need to do a Docker log out. Okay. And so now we get an error saying, this doesn't, what are you talking about? pmkey, sorry. So image does not exist locally with the tag pmkey getting started. And so if we run the docker ls command, that'll give us a list of images that are on our machine. So let's do that now. Docker ls, I'm sorry, docker images. Let me clear that. So this tells me what images I have on my machine. And you can see I have the getting started. It's the latest, and it was just created about 4 minutes ago. But we don't see any with pmkey / getting started, right? And so what we're going to do is we're going to use the docker tag command, which takes one image and tags it, creates a link or a tag to that image with a different name. And so right here is the docker tag command. And of course, I got to put my username in there. Now, this can be anything, but since we're going to push it up into Hub, you need to tag it with your repository name. So when you do a Docker push, Docker knows what repository this image lives in, right? So now if we do a Docker images, now we can see, oh, there's my image right there, okay? And so now after we tag it, we can now push this into Hub with the Docker push. So Docker push, pmkey getting started. Uh-oh, we've been denied, right? And that's because I need to do a Docker login, username. Okay, now let's do a Docker push. And there we go. It's pushing the image up into Hub. Okay, awesome. Okay, so now our image has been pushed up to the Hub. We can go test it out and pull that image back down to another machine that's running Docker. So we'll do that. We're going to use Play with Docker to do that. So Play with Docker is a lab that we have. It's this one. So I'm going to log in with your Docker ID. Okay, and then click Start. And that will start up Play with Docker, and then we can do create a new instance. Give that a second to create it. And there we go. We are in a virtual machine that's running in the cloud that has a Docker instance running on it. So if we do Docker version, we can see we have 1903. We have our client and our servers running. And so let's go ahead and run the command that we did earlier, but this time we're going to, our Docker run -d-p 3000 to 3000. But this time we're going to put our repository name, our hub Docker ID in there to tell Docker on this other machine where to go get that image. All right. Before I do that, let me show you. So let's run a Docker images on this VM, this instance we're looking at right now. And you can see we don't have any images. So if I just did a Docker run and I just called it getting started, getting started, Docker would look locally and not find an image that's named that. It cannot figure out what the repository is, where to look on hub, because getting started is not an official image. So it's going to tell us, well, I don't know where that's at. So that is why we need to add in the repository name. We'll let that run for a second. Okay, there it is running. And what's really cool about Play with Docker is after you did that, it knows that you've exposed the port. And so we can click on this link and that'll open our app that's running up here in the cloud on this instance and gives us a link into it. And so we can interact with our application. Okay, cool. Pardon me. Okay, so now what we're going to do is, one second. Pardon me, I had to sneeze there. Okay, so right now we're not persisting data. As you saw before, once I hit either stop the image and restart it, our to-dos have gone away, and every time I hit refresh, they go away. So what happens is the container file system that runs with Docker, it's a layered file system. So each layer, every time you create, update, or remove a file, a new layer is created when we create our Docker file. And then at runtime, Docker creates a new file at the very top of the stack of the file of the layers. And that's where all your files are written to or read from. And once the image is stopped, that layer that was there at runtime goes away. It's not persisted, right? So we can see that in action. So we'll start a Ubuntu container, and we'll create a file, data.txt, and which will put numbers, random numbers in there from 1 to 10,000. Okay. So let me explain this command right now. So Docker run, same Docker run that we saw before. We know what the -d is. That's going to run in the background. This is the name of the image, Ubuntu. And again, we don't have a repository in front of this because Ubuntu is an official image. And then this right here is the command we're going to pass into Ubuntu. We're going to tell it start bash. I forget what the -c is. And then we're going to run this little script, which basically loops from 1 to 10,000 and then writes that out into a text file. And then it's going to tail that text file so we can see each of those numbers being written to the file. Okay. That talks about the command. And so now we're going to take a look at the data that's being put into the file, right? So we're going to exec or execute into the container. And the way we can do that here is we're going to use the desktop to do that. Let's come over to desktop and we can see all of our containers running, and there's my Ubuntu. So I'm going to click on the little CLI button, and we're going to get my other bash. Okay. So let's cat out in the root of that file system data.txt. So you can see that file is right here. So let's cat that out. So go cat, and we're going to go data.txt. It's at 6318. Oh, no, it didn't like that. Okay. So it went to 6318. So let's do the same thing from the command line. So let's terminate that. Terminate that. What this CLI command does is behind the scenes, it's going to do it does the exact same thing we're going to do here in a minute on the command line on the terminal. So we're going to so we're going to docker exec. We're going to give it an IT. We'll give it the container name, and then we're going to cat out the file just like we did in the from the Docker CLI when we clicked on the CLI up here. So let's actually get the Docker container ID, which is that. So we're going to docker exec-it container name, and then cat whack data.txt. And so what this does, it says execute a process inside of that container. Give me an interactive terminal. This is the container ID that I want you to run the command in, and then it's going to run cat and then data.txt. Since we ran it with an interactive terminal, it's going to grab the output and dump it into the screen. Okay, and now we're going to run a second container. And so we're going to run a second Ubuntu container. We're going to run it with an interactive terminal, and then we're going to pass an ls, which is list, and we're going to tell it list the root directory. And there we go. And you can see that we don't have the data.txt file in this Ubuntu, right? And what this is demonstrating is that we're writing to a file in our other image, in our other container that was built from the Ubuntu image, but those files aren't being saved into the image. They're going to go away. Okay, so let's go ahead and remove both of those. So we'll do a docker ps, docker remove -f. So remove with a -f forces the image to stop and then be removed. If you try and remove an image without first stopping it, you'll get an error. So we're going to remove it, but we're going to tell it to force. So go ahead and stop it first. And this is friendly Rosalind. PS. And there we go. It has been stopped. Okay, so now we're going to talk about containers and volumes. So volumes are the preferred way to persist data. And there's two types of volumes. We have volumes, which are named volumes, which are managed by Docker. And then we have bind mounts. And bind mounts basically bind your local file system into the container. With a volume, Docker creates a volume outside a storage area outside of your container, and then maps that storage area into your container. And so anything written to that that area will be stored in the volume outside of your container. And therefore you can start and stop containers, attaching them to this volume, and your data will always get written to the volume and always persist. Same with the bind mount. You can map, let's say, your local working directory or your temp directory into a container, and anything written to that temp directory inside a container will get persisted to your local file system in that temp directory. So by default, the To-Do app stores data in a SQLite database located here, etc todos todo.db. So with the database is a single file, our container writes to the db.db file. And so we're going to create a volume to store this todo.db, right? And so let's go ahead and create a volume. It's very simple to create a volume. Let's clear that again. So just doing a Docker volume create, and then we give it the name of the volume we want to create. And there we go. It's been created. And now we could stop the our to-do app in the dashboard or using the Docker rm-f. And then when we start it back up, we're going to map in the volume into etc to-dos. So let's find our image, is this one right here. So we're going to go, not image, container, sorry. Docker remove -f, and we're going to give it the container ID. Docker PS, it's gone. Okay. Now we're going to start it back up, but this time we're going to map in the volume into the container. So when our data is being written into the SQL database, that it will get stored, and we were able to then stop our container and start a new container attaching to that same volume that we written to earlier, and our data should persist. So there we go. We have our container running. It is this first one right here. So now that it's up and running, let's go ahead and go add some stuff into our to-do. Very important. We can delete this. Let's leave that. Okay. Here you can see. All right, so let's add some stuff. Get milk. Get car washed. Cook dinner. And finish workshop. Okay, cool. So now we're going to remove the to-do app, right? So we'll run a PS to get the ID, and then we'll run the -f command like we've been doing previously. Okay, Docker PS. And here it is right there, the 035D4. Or if we wanted to, we could actually use the wonderful Bose. Remove -f and catch the W. Okay. You can see it's gone. And then we're going to start a new container as we did above, and then we'll see if our data has been persisted. Okay. Let's refresh. Oh, we have data. Let's do this. Docker stop. Let's get a list here. It's that one. So let's stop it. Okay, we don't have any data. It's been stopped. Now we're going to start it up. Okay, let's refresh, and our data is back. Awesome. So now we're able to persist data instead of losing our data every time our container stops or starts or is removed. Okay. So Docker volume ls. We can take a look at what volumes we have on our system by running Docker volume. Here, let's do the help, if we can spell correctly. So this gives us all the options we can do with the volume command. So we can create, which we did earlier, we can inspect, we can list them, and then we can prune them. So that'll remove all unused images, and then we can remove them. So let's take a look at the list. So we're going to do Docker volume. Make sure to it's not volumes, it's volume, noun, singular, and let's run an ls. So you can see here's my to-do volume. This is another volume that I was using for a different workshop. Here's our to-do, right? And now we can inspect that and see what's all involved with this volume. So to-do, ooh, there we go, DB. And there's some different properties in here. It's spit out as JSON. So it tells us the create date, what driver is being used. You can use you can put plugins for different drivers. You can add labels to your volumes and containers and those type of things. And then this tells us the mount point. Now this mount point is not, when you run Docker desktop, since Docker runs all of your containers as a process, a native OS process, that means you use the underlying operating system to create containers. And I'm running on a Mac machine, which is not a Linux operating system. It's a BSD-based OS. And so the underlying constructs of the operating system are not the same as Linux. So what Docker Desktop does is it creates a small, tiny little VM, and it runs the engine inside of that VM. And then it wires that engine up to the CLI outside of the VM that's running in your terminal. And so when we run images, we're running native Linux images inside of an image VM on my Mac. Same exact thing happens on Windows. Of course, the implementations are different on the two OSs, but the design and architecture is the same. So this mount point is actually inside the VM where Docker engine is running. So I can't cd into lib docker. Tells me no such file, no such file exists. It's inside of the Docker VM that's running the engine. So I just wanted to call that out in case you do this and then you try and cd change directories into this to see your data. It's not there. Okay, and then it names it, and there's some other options, and then tells you the scope. Okay, let's take a look at bind mounts. So I talked a little bit real quickly about bind mounts earlier. So like I mentioned, so name volumes is the preferred way that Docker would like you to manage volumes. That way, if I create a Docker file or run a file and I use volumes, it'll be run the same whether it's on your system or on my system. It's not dependent on the directory structure of your local system. With bind mounts, you basically bind the local data structure, file system structure into the container. So if on my machine, I was located, I had my data located in the root on /data directory. And on your system, you didn't have it right in the root, but you had it in your home directory. So if I sent you an image and I told you, oh, hey, do a bind mount and bind the root data folder into the container, your data folder is going to be different than mine. And let's say you pull down code from get, and it's not living in the data directory. You're not going to see those inside the container, and there's a little bit of confusion. So that's why we recommend using volumes. If you use a volume, it's always going to be in the same place. Docker manages that. But bind mounts are very, very helpful, especially for local development. I use bind mounts a lot when I want to do local development. So starting in dev mode container. Okay, to run a container in supported development workflow, we're going to mount our source code. And this is kind of what I was talking about. This is how I do local development a lot. We'll install all the dependencies, including the dev dependencies. We'll start nodemon and watch the file system, okay? So let's stop all of our images. Docker ps-a, Docker ps remove that, whoop, not ps, remove -f, and it looks like 974. Oh, by the way, with the container IDs, you only have to pass in enough of the beginning of the container ID that makes it unique. And Docker knows, okay, this container starts with 974. I don't have any other containers starting with 974. I know what you're talking about. And while we're at it, I'm going to remove that Ubuntu. Okay, let me clear and then do a Docker PS. And there we go. We only have our tutorial running. Okay, so we're going to run the follow command. It's very hard to see it here. So let me copy this out and let me paste it. So again, we're going to do our nice Docker run that we're familiar with, the -d and -p. So -d for daemon, so running in the background. Detached is, I believe, what the D actually stands for. And then -p, which is publish a port. And we're going to publish 3000 on our host into 3000 in the container, like we've been doing. And then we're going to set a working directory is /app. And then we're going to do a mount, a bind mount. And we do that with the -v for volume. And then we tell it pwd, which is print working directory. And this little $sign says execute this command and then grab the output and replace it with the output. So what this will do is run pwd, which shows me pwd gives me my current working directory or print working directory. So users Peter. When I run pwd here, I'll get sandbox getting started, g started app, and it'll map that just like we did here, port on your host into the container. We're going to do on a host locally, my working directory, and I'm going to map that into app. And then this is the name of the container we have, and then this is the command we're going to run inside of that container. So it can't find node 12 Alpine. It's going to pull it down locally. And did it run the whole thing? Do a Docker PS. Let me clear that so you all can see that. This is my image here. Oh, yep, there we go. Wanted to make sure it was running yarn. Let's do this. Let's do Docker remove -f. Oh no. F00. Okay, now it's gone. Docker PS, it's gone. So we're gonna do that Docker run again, but this time I'm gonna take out the background. So we can see it actually running and resolving. It's doing the yarn install, and then it's gonna do the run dev. And you might be asking, oh, well, wait a minute, how's it gonna get the code? Where does it see the package? You didn't copy it into the image. And that's what the bind mount does. That'll bind my working directory, pwd, into app. And you can see this is the folder that's inside of my working directory. And so all of this will be available to the container. So when it runs, it looks and goes, when we ran the yarn install, it says, oh, there's my package JSON. So it gets all dependencies. And then when it runs the yarn run dev, it looks in the package JSON, looks at your scripts and sees we have dev, and then it's going to run the nodemon source.index. Real quick for those non-node developers, this package JSON is your dependency kind of management, but it also has the ability to add scripts to it with labels and then a command. So you have label, prettify, and then you have the command that it will actually be run. So here with dev, when we say yarn run dev, it looks inside of here, says, okay, underneath my scripts, I see a dev. oh, it wants you want me to run nodemon source / index.js. And so what will actually be run is that nodemon. And you can see that right here. So it's going to start node, actually right here a little more specifically, which in turn runs node, the source and the index. And now we're listed on port 3000. And there we go. You'll notice that we don't have our data anymore. That's because we didn't mount in, we didn't bind to our name to volume. We used a bind mount just to our source code and not into the SQLite database. Okay. Okay, we watched it using ourselves running it without in the background. Okay, now let's make a change to the app. So let's make sure. Okay, it's still running. So we're going to make another change to the app. I really got to change these colors here. That's horrible. So line 109. Let me do it below. So instead of printing out adding, so when we click on the button, this submitting flag changes to true, and it should say adding. When it's done adding, the submitting button will be false, and it says add item. All right. So we're changing add item to add. So this should be the default. Let's get rid of that. Save it. Now you notice we didn't remove our container, rebuild, and then restart the container. We just updated some code. So let's go look at the application. So you can see it says add item. Let's update it. Oh, now it says add. Let's do that. It should say, it goes really fast because we're running locally. But you can see that changed, and I was able to change it without starting and stopping the container, rebuilding, all those type of things. Why? Because we have mapped in our source code into the image, and then we told the image, go ahead and run this in dev mode and watch my files on my file system, and when they change, recompile everything and restart the app, all inside the container without stopping the container or restarting it. Okay, so let's stop it and let's rebuild our container. I'm gonna stop it on here. Yeah, let's remove you, and we're gonna remove you. And there we go. So I'm gonna rebuild it. Okay, while it's running, we can move on. Basically saying that bind mounts are very common for development setups like we just did. Super common. I use it all the time. It's really easy to just bind mount in your source code, configuration files, those type of things. Run your application inside of a container, and that way I can have the specific node version that I need to run that application. And then in another window, another terminal, I can run another image that's of a different version of node, and I can map in my source code and develop on that version of node, right? And I don't have to install node on my machine. I just run it inside a container. I map in my source code and I'm able to run it right inside a container just like I would normally on my terminal. Okay, so now is this done? Yep, we've rebuilt. Let's clear Docker images. This is the getting started I just built 53 seconds ago. Okay. All right. So at this point, we've been running everything inside of one container. We're running MySQL as a embedded system and writing to disk and all those type of things. So we're going to take a look running multiple containers and running MySQL as its own container. So To do that, we got to talk a little bit about networking. Okay. So when a container is run, it's isolated, and that includes the network. So it's put onto its own network. It's not able to see any other containers outside of it, unless it is on the same network as that container. So what we're going to do is we need to create a network that we can share between our two applications. So let's do that now. So we're going to create a network. Creating a network is very similar to creating volumes. So we just do a Docker, and let's do the help here too. But so here's a command you can run. So we can create, we can inspect, and we can list like we do with volumes. We can also connect or disconnect from a network, and then we can remove them. Prune, we also have prune that remove all unused networks. It's a nice, handy way to clean up things that aren't being used anymore. So let's create our network. Create, and what did they call it? To-do app. To-do app. Okay. Docker network ls. And you can see here's to-do app. Okay. Now let's start a MySQL container and connect it to that network. Okay. And then we're going to use environment variables here to pass in the password and the database. So let me read this command, explain it real quick. So again, Docker run, very familiar with that. -d, familiar with that. Now we have something new. We have the network. So we're telling it attach this to-do app network that we just set up. We're going to tell it inside that network, I want you to be able to reference this container by the name MySQL. It's called a network alias. And then we're going to map a volume to do MySQL data into var lib MySQL. We're going to set some environment variables, the password and the database, and then the name of the image. It can't find MySQL locally, so it knows that since it didn't have a repository in front of it, it knows it'll look at the official images and says, oh, okay, I know what image that is. So it pulls that down. And let's do a Docker PS, and we can see our MySQL is running right there. Okay. So we're going to exec into here. So if you remember what exec does, that executes a process inside of a container. So Docker exec, we're going to give it an IT, an interactive terminal, and then we're going to have to put in our container ID here. Make sure I have a space, yep. And then we're going to tell it run MySQL. That's the command line tool to interact with the SQL database, SQL engine. And we give it a -p. And what was the password? Secret, very secret password. Okay, now we got a MySQL command line tool that's connected into the database. And then we're going to run show databases. And there we go. We can see to-dos down here at the bottom. And hooray, we've done it. Okay. So now we know we have our MySQL running inside of a container. We're able to connect into it. We are able to see the database. Things are looking good. And I think yep, there, exit out of that. Okay. So now we're going to take a look at some networking and how to talk back and forth between these. These are some DNS tools, networking tools we're going to use. Okay. So we're going to run Docker run, and we're going to attach to the to-do app, and we're going to use netshoot. So let me clear this. So it's going to pull down the netshoot image. I'll get a drink of water here. O2 folks, if anybody needs to drop, it's totally fine. We are recording this and we'll send out the replay afterwards. If you miss it, we're also going to do this again next month. So don't worry too bad. If you got to run, totally understand. Thank you for coming. Sorry we're running late. This usually takes a little bit longer than an hour. So, but we're almost done. So, okay. So now we're inside of the container, and let's use the dig command, which is a DNS tool. So to look up the IP of MySQL. Okay. So we got an answer, we got a header, MySQL, and I believe the IP is right here. Okay. Yeah, so A is for the A record, for the MySQL, and it resolves to, oh, there it is, I'm sorry. 172.19.02. Okay. And you can see that because we use the network alias, we get MySQL returned to be able to look it up from other containers or hosts running on that network. Okay, so the to-do app supports some environment variables that we can fill out so we can connect to the database. So MySQL host is the host where the SQL server is running. MySQL underscore user is the name of the user, underscore password is the password, and DB is the name of DB we want to use. Okay, so right here's a quick warning, and it's highly discouraged to do environment variables with secrets. You can read down through this, but a really good blog post to read is this one here, why you shouldn't use environment variables. Definitely read down through this. It explains what's happening, why you don't want to do it, all those good things. I don't want to dive too deep into it in this tutorial. Okay. Now let's connect. Now let's start up our, pardon me, our dev terminal. So I'm going to copy that. I'll explain what all this is when we run here in a second. Okay. I'm going to remove this net shoot. Docker remove -f. Okay, that's clear. Oh. Okay. So again, Docker run DP. So as detached and expose the port. Set up the working directory, map in our bind mount our local working directory in the app like we've done before, join the network. And now here's where we set up our environment variables. So we're going to tell it the host is MySQL, the user is root, the password is secret, and the database is to-dos. And then we're going to run our node Alpine image, the official node image, I should say. And then we're going to run a shell command. We're going to say yarn install and then yarn run dev. And then let's take a look at the logs. I'm going to tail them and let's see. Yep, that is it there. Okay, and there we go. It's all ready to go. Everything's been resolved. The reason being, let me clear this here, ls. Okay, so you can see the node modules right here. When we ran the dev environment before, because I mapped in pwd, which is my print working directory. So this is my current working directory. It mapped that into the container. So last time when we ran the npm install or the yarn install, forgive me, it wrote everything to the node modules. But since that was mapped to my local file system, those installs were persisted. So when we started a new container with the same image and mounted my local working directory again, and then ran the yarn install, this yarn install looked and said, oh, there's your node modules. Everything is installed already. I don't need to run again. Oh, that's right. We already ran it. But let's pull up. So you can see here, resolving packages successfully already up to date. And now we're listening on waiting for MySQL. It's been connected and we're connecting with the host. And now we're listening on port 3000. Let's get milk, get coffee, get chicken. That's good enough. Okay, cool. So let's say that one's done. All right. So this just is explaining what I just explained. Looking at the host. Now let's go back and let's execute into our another terminal here. Let me bump this up. And I could do that. Yes, nice. Okay. Whoops, I'm gonna need the Docker PS. I'm gonna need the ID. So Docker exec -it. And what we're gonna run, MySQL -p.todos. Yep. Uh-oh. Did I run? Oh, no. I'm sorry. I was trying to connect to the wrong image or container. We need to connect to the MySQL container. So if you see here, DBC0 is the node. And so what this said is, oh, when I tried to run, when I tried to execute MySQL, it failed. I don't know what file that is because it's not in our node container. It is in our SQL container. So Docker exec -it, the correct container ID, and MySQL -p todos. See, I probably just, oh, I spelled it right. Okay, cool. And then let's run this little select command to look at what to-dos that we just saved. And there we go. You can see get milk, get coffee, get chicken. So our two containers were able to talk to each other, right? This is just showing that we can now see them all. Let's get rid of that guy. But you can see all of our images running. You can see our SQL server running, or not SQL server, pardon me, MySQL running. And then our node application is running. Okay. So what we just did there is we started each one of those containers individually. We had to start up our MySQL container. We had to remember all the command line options. We had to remember what ports, what environment variables were named, all those type of things. And we had to type that all out on the command line. Of course, I copied and pasted out of the tutorial, but in the real world, you would be typing out all these long Docker run commands, right? And you might say, well, let me put those into a script, bash script or something like that. And you could do that. But Docker has a solution. It's called Docker Compose. And what Compose does is just that. It composes different containers and allows you to run those containers at the same time, connecting to networks and volumes and passing in environment variables. Everything we did on the command line, but we had to type it out for both our node container and our MySQL container. We can put all that configuration into a compose file and then just run the compose file, right? So we don't need to install compose, we already have it. Compose is installed with Docker Desktop. Let's docker.compose version. And there we go, we have version 127. Okay. Okay, so this is just reminding you of what the big command that we ran. And so we're gonna take this big command and we're gonna convert that into a compose file. And I skipped that. So let me go into our app. Let's create a new file. Okay, cool. Okay, first thing we need to do, I think it's rewritten down here. Yep. Let me just, I can just hit the copy button. Actually, let me do this. This is going to be way easier if I just go down and get the final one. There we go. Paste that in there. Okay, cool. So at the very top, we tell Docker Compose what version of the Compose spec we're using. So we're going to use 3.7. And then we have this top level label called services. And then underneath the service, we list out our services. And a service is basically a running container. And so our first service is named app. This is arbitrary. This could be, you know, it could be our app, it could be front end, you know, back end, whatever you want to call it. But it tells it's the name of the service. And then we tell it what image to run. So we're going to use again the node 12 Alpine. What command to run and to pass into that image, just like we did on the command line. And then we tell it expose port 3000 and map that into port 3000 inside the container. We're going to set up our working directory just like we did on the command line. And then we're going to map our volumes. Here in a compose file, instead of doing pwd like we did on the command line, you can just give it the relative path to your local file system. So we're going to tell it use the current directory I'm in. And then we're going to pass in some environment variables just like we did on the command line. So we pass in the host, the user, password, and the DB. So let's save that. So that's this is for our app, our node application. Now let's take a look at for the MySQL. Again, this is showing everything we typed out on the command line, and I had to put these nice little backticks so we can do multiple line command lines. And I'm gonna, whoop, okay. So I'm gonna scroll down, pardon the, okay. I'm just gonna grab the MySQL from here with the volume. And let me explain what all this does. Okay. Let's go to the bottom here. Okay. So here we're going to set up our second service called MySQL, which is going to hold our MySQL database. Again, we tell it what image to use, MySQL 5.7, just like we did on the command line. And then we're going to map our volumes in. We are using to do MySQL data volume, right? And you can see that down here at the bottom, we have a top level, primary level label called volumes. And underneath that, we list out our volume. And what this translates to basically is Docker volume create to do MySQL data. And so this command is basically what these two labels represent. Okay. And then we're going to pass in our environment variables. So tell it what password we need to use for root and what database we want to use. Okay. So now we can run our application stack is what it's called in Compose. And so let's make sure nothing else is running. So Docker PS, Docker remove -f. We're going to remove node and we're going to remove MySQL. And as you can see here, you can list out multiple containers and they'll both be stopped. So stopped and removed. So there we go. We still just have our tutorial running. Okay. I'm going to go back into here. Okay. So the command we're going to give is called up. So we're going to say Docker compose up. And what up does is it tells compose, just read in the compose file, look at my services and start them, right? Bring them up. And then we're going to pass in a -d, which is the same as a Docker run. It's going to run it detached. Okay, so we created a network, app default. The app comes from, can't highlight in the command line. The app comes from, compose looks at the folder or directory that you're running in, and it'll use the name of that directory as a common prefix to everything it creates. And so it's going to create a network, and so it says app_default. It creates a volume. Remember, this is what we named it in our compose file. But so we don't have clashes and those type of things, it'll prefix it with the name of the directory. You can also set this when you run Docker compose with a -- project. So, oops. It's either at, it might just be at the compose level. Here it is, yep. Project name. So we could do, when we ran it, we could have gave it a -- project name or a -p and told it, don't use the directory or folder I'm in as the project name. Use this name instead that I'm going to give you. So in case you have interesting directory names that aren't very descriptive. Okay. So we can also take a look at the logs using Docker Compose. So we'll use Docker Compose -f to see our logs. And here we can see all the logs being dumped out by both of our containers. And you'll notice here that we have Mysql, and then down below we have app1, right? Which is app is coming from in our service is called app, and Mysql_1 is coming from there also. So you can run multiple instances of these containers. And here we could define run 2 containers and not just one. The default is 1. Very rarely running local will you run more than just one. But it'll give it a counter of which one you're actually looking at. So we can see our node is up and running and listening on port 3000. So let's go and open up our app and see it running. Let's refresh. Okay. These start getting smaller and smaller as we go. Gas, cheese, food. There we go. There they all are. All right. Oops, I always Alt Tab instead of the other tab. Oh, let's go look at this. Is very interesting. So let's go look at the Docker dashboard. If you noticed before, I was saying containers and apps, but we only saw containers running. But here with Compose, it'll also show your Compose applications running in the desktop in the dashboard. So you can see we have app, and then we have this little arrow that we can expand it and then see what containers make up this app. And we can see we have our Mysql, and then we have our app1. And the same things we can do here. We could connect into Exec into, oh, no, I hit the wrong one. You can open it in the browser. The reason that is there and not above that is because we're exposing a port. And Docker Desktop smart enough, just like Play with Docker, sees you exposed a port, says, oh, okay, cool. Let me give you a little shortcut to click on this button so you can open that URL in a browser. Okay, awesome. And so this is just what we talked about here. So to bring everything down, we're going to run a Docker Compose down. Let me stop the logs and let's clear this up here. So I'm going to do Docker Compose down. So it stopped the containers, then it removed them, and it also removed our network. But what's interesting, we do a volume ls, we'll see we still have the app to do MySQL data volume is still there. It didn't remove it. But if we did a Docker network, you can see that our app underscore to do network has been removed. Actually, app underscore default, excuse me. It's no longer there, it's been removed. But the volume will stick around. The reason being, if you save data into that volume, you want that to persist while you could do Docker compose down, Docker compose up, Docker compose down. We want to keep that data around as long as we want. And let's bring it back up just so you can see that. There we go. And let's do that so it doesn't look like magic. And there we go. We still have our items. It's running in that MySQL that we started all with just compose, just firing everything up all together. Let's stop that. Okay. So we are about at time. This next kind of section is kind of optional, so I'm not going to go through it too much, but it talks about scanning images and those type of things. I really recommend that you go to our GitHub. Let me drop it into the chat here. Highly recommend. I know I went very fast and I was explaining a lot of things and I didn't read through the text. I didn't want to bore you with just listening to me read the tutorial to you. But I highly recommend go to this GitHub repo and run this Docker run command right here. The only reason I say go to this repo is because that's where the command is. You don't have to remember the command. It's easy to remember Docker / getting started. So go there, run this command. This will pull this image down, this tutorial image down from Hub, and it'll start it on port 1000. And then you just open up your browser and you can follow along. I would go through it all and then go through the last module there at the end, which is basically extra credit. Gets a little deep into scanning and images best practices. I recommend that people try to build their own images for some smaller applications they're working on and running those, connecting to database and those type of things before you really worry too much about best practices and getting the smallest images possible and all those type of things. Walk, crawl, run. So, or crawl, walk, run. In the crawling phase, when you're first starting out, and in the walking phase, right, start slow, understand the concepts first, get things working and running. Then once you understand those, now dive down another deeper level and start understanding why you're doing the things that we're doing and how you should be doing it, right? Best practices. Okay, well, that's all I have for today. I really appreciate everybody coming around. And actually, if you would like, I'm going to look at the questions real quick. I know we're past time, but I still want to take a look at the questions and see if there's anything I can answer real quick. Are there plans to release Docker Desktop on Linux? There's a bunch of requests for Linux, Docker Desktop on Linux. And if you would like to see Docker Desktop on Linux, the best thing to do is to go to our roadmap. We have a public roadmap. It's on GitHub. So if you go to GitHub /Docker /roadmap, and I'll drop that in the chat. So go to our public roadmap. That is our public roadmap. We do use it. We submit our own issues there. The project managers are there. Our CEO even takes a look at it from time to time. Our VP of product is in there. So we do use that. We do have an item in there for Desktop on Linux. Please go upvote it, add some comments, get involved in the conversation. let's see. Yes, it's being recorded. I get a lot of those. Yes, you can download it from that GitHub. Go to the GitHub repo, docker/getting-started, and you can follow along right there. Thank you all for helping me debug as I'm going as I'm going along here. Folks, put in the questions that yeah, you can't have the error we were getting with the HTML. It has to be wrapped in a div. Why does everybody install new packages right within the running container? Ali, yeah, it's definitely not something you would do outside of a development environment, 100%. So if you're in production, if you're in, some other server where your app is running and you've made a change, right? Do not SSH into that VM, run a Docker exec, do a get pull and update your code inside that live container. Ali's right. That's not the way you want to do it. You want to build another image. You want to push that into your CI/CD pipeline, and that should update your image in whatever orchestrator you're using in production. If you are only using one Docker engine, let's say running on an EC2 image, right? Still do the same thing. Build your image, push it to hub. Then you can either use the Docker engine to point into your EC2 instance, or you can SSH into that instance and just stop that container and start a new container with a new image, right? That's the way to do it. But running locally and developing, totally fine. You're not saving them into the container, you're saving them local onto your file system. It's just one way to develop inside of containers. Again, at the base of it, at the very base technology of containers is a process. It's the exact same process when you're on your terminal and you run yarn run dev, you run it locally in your terminal. That process is started. It's the same exact process that is started inside of the container. The main difference is the process inside that container. Docker uses namespaces and C groups and some other things to secure that process and not allow it to break outside of it. That's the only difference, right? Completely different than VMs. VMs are not even close to what containers and images are. Okay. Does Docker Desktop exist for UB? Not sure what UB is there. Ubuntu, maybe? Desktop does not. Desktop's only available for Windows and Mac. Linux, you can download Docker from our site, and you can get binaries and those type of things, or you can download the source and compile it. Hatham, how can Docker run Windows containers on Linux? It can't, unless they're run inside of a VM with the VM running a Linux OS. And technically, you're not running a Windows container on Linux, you're running a Windows container on Windows. Oh, I'm sorry, my example, I messed that up. So you have a Linux host OS. To run Windows containers on a Linux machine, you cannot. It's impossible, and vice versa. You can't run Linux containers on side of a Windows machine. The reason being they share the same OS, and so a Windows container is looking for a Windows OS, so it's going to use the Windows exe kernel, and it's not there. So you have to put a Windows inside of a VM, so you have the OS, and then you can run your Windows containers inside of that VM. All right. Again, it kind of goes down understanding at the very base level, it's still using the operating system to start a process. Oh, there it is. Yes. So does Docker Desktop exist for Ubuntu? No, not Docker Desktop, but Docker does 100%. Can you run Windows Desktop app on Docker? I think, Joanne, I think you might be asking, can you run a GUI app, like a Windows application in Docker? Yes, you can. You just need to wire up the ports for Xterm and all those type of things. You just need to give that process access to the UI of the operating system so it can paint into the UI. But yep, you can 100% do it. There's a couple good DockerCon talks. I believe we actually have one this year, So just Google DockerCon 2020. It's in our YouTube channel. So actually go to our YouTube channel, which is YouTube/Docker Run, and search for running Windows GUI apps in Docker. So it is https:/, I think it's youtube.com/Docker Run with 2 R's. Is it secure if we deploy on hub? Meaning if I use an app with real data? Yeah, absolutely. Docker Hub is secure. You can create private repos. In the example, we created a public repo. And you have to be the owner of that repo to push to it. So not everybody can push to your public repo, but everybody can pull from your public repo. If you want to have it completely private, you can mark that that repo as private. Yes, Michael, it's recorded. Is it possible to make Docker build automatic, something like hot reload after updating the app? Dario, forgive me if I'm pronouncing that wrong, but not right now. But yeah, that's a very, very highly requested feature that we get asked to a lot. We're the PM team, the product management team, is talking to a lot of developers on how they work, what they do, and that question is asked a lot. And I don't think it's in the works yet, but we're really looking into what's the best way to do that, right? Exactly, because right now you have to stop your container, rebuild the image, restart your container, and go. With BuildKit, that loop is a lot faster, but it's a pain. It's a pain for sure. Yeah, so we're looking into especially deving with that dev life cycle. We call it the inner loop here at Docker. So the developer inner loop of coding, debugging, and coding, running, and debugging, right? And so look again, if you want to go out to the roadmap, the link's in the chat, go there, either find that feature that's out there or add it if it's not, and then tweet it out so everybody else sees it and can go comment on it. Okay, I think that's it. Yes, Naveed, we will definitely have a recording. I believe it'll be sent out after we finish, not immediately, probably tonight, if not tonight, tomorrow. All right. Well, thank you so much. I really appreciate everybody. Maxime. Next course, Docker Swarm. Docker Swarm's interesting. I love Docker Swarm. Love Docker Swarm. That's what I ran internally. I ran all of our internal knowledge base, our external knowledge base, our enterprise portal, our training platforms all ran on Swarm, and it ran great. But now at Docker, we're not so much focused on Swarm. Swarm went over to Mirantis, who bought our enterprise software. And I'm not 100% if they're still actively working on it. You're welcome, everybody. Thanks for joining. I really appreciate it. Connect with me on Twitter at PMckee, PMCKEE, or connect with me on LinkedIn as another place you'll find me. Those are probably the two places I'm at. I'm also in the Docker community Slack. If you're not in the Slack, please join. There's a bunch of great people in there. A lot of our captains are in there, answer questions. And feel free to reach out to me. Again, I always have a caveat. It's very hard to help troubleshoot specific issues in Slack or in Twitter, but I will do my best. Awesome. I hope everybody enjoyed it, and thanks for sticking around for so long. I really, really appreciate it. Have a great rest of your week.